Hello, folks. Hi, this is Ruchita Arora. I'm the Senior Product Manager for Amazon ElastiCache. And today we're going to be talking about scaling Redis workloads with the Redis cluster available from Amazon ElastiCache. So a quick sort of overview of what I plan to cover in this session. We will be talking about Amazon ElastiCache overview, Redis cluster benefits, specifically drilling down into scaling your cluster with the online resharding capability that is available with Amazon ElastiCache. We'll also talk about read scalability, and then we'll wrap it up by just summarizing all the options available in terms of scalability with Amazon ElastiCache, including use cases and best practices. So before we actually get into ElastiCache, let's just take a step back and talk about why ElastiCache is important. Today, as we all know, the big trends in technology include mobile applications for use cases such as streaming, online gaming, IoT, high frequency, financial trading platforms, you name it. And the common tenet along all these use cases is the need for low latency and very high concurrency. So we sort of live in this era where you need real-time responses for pretty much everything, right? And we are undergoing a digital transformation where not only the mobile apps, but also B2B applications that are being developed today need the microsecond response times and the ability to support millions of users concurrently. So over the years, developers have used these various approaches to reduce latency and improve concurrency, such as in-memory databases and grids, specialized hardware, or other data reduction approaches such as sampling, aggregation, etc. But these don't work very well, and they're sort of difficult to manage, resulting in poor experience, issues with scaling, and often adding up into cost. This is where Amazon ElastiCache comes in, where it offers, both Redis and Memcached, the two most popular key-value stores, offering super low latency and in-memory performance, which is extreme performance, and offers a fully managed experience that allows you to sort of deploy, operate, and scale these services. Amazon ElastiCache for Redis is a blazing fast in-memory data store that not only provides you sub-millisecond latency to power those real-time applications we talked about, but it's also built on open source Redis, and it's compatible with the Redis APIs. So it works with Redis clients and the ecosystem that you might already be familiar with. And your self-managed Redis applications can seamlessly work with Amazon ElastiCache without any code changes. With ElastiCache for Redis, you get the speed, simplicity, and the versatility of open source Redis with the manageability, security, and scalability from Amazon to power your most demanding applications. Now, Redis is, as we know, is one of the most popular key-value stores. In fact, it's the #1 key-value data store that's available today. And the reason why it's so popular is it's very easy to use, extremely versatile with its flexible data structures, and so it allows you to meet your application's needs in terms of, whether it's geospatial indexing, ability to use sorted sets, and various data types that are available, such as hyperlog logs, which each essentially provide a unique capability in terms of using your data set. And so simplicity and ease of use of Redis enable you to sort of get started as well with very few lines of codes and quickly scale and address your performance and in-memory needs for the application. With ElastiCache for Redis, not only you get all of the Redis capabilities we just talked about, but it's also hardened by Amazon. So I'll quickly talk about very specific capabilities that we've added with ElastiCache. So first and foremost, of course, AWS manages all the hardware and software configurations for your cluster, right? So it is monitored 24/7 by our monitoring software that can trigger alarms if anything goes wrong or take corrective actions as necessary. All these metrics that are being used, whether it's CPU, memory, network traffic, all the metrics are actually available for both the core master or the primary node as well as the replica, and it's fully integrated with the CloudWatch for your detailed monitoring needs. Along the way, we've hardened ElastiCache for Redis significantly with improvements such as optimized swap memory management during syncs and backups, smoother failovers, and also, handling scenarios such as write throttling in extreme cases where you are experiencing peak write traffic. So making it overall more robust and more scalable. With ElastiCache, you also get the additional benefits of security and compliance, which is truly making it ready for your enterprise needs. So for example, number one being, of course, Amazon ElastiCache has full support for VPC, providing you isolation for the cluster to the chosen IP range. ElastiCache includes enterprise features such as encryption in transit, at rest, and support for Redis Auth for your token-based authentication with the cluster. In terms of just the manageability aspect, whether it's encryption in transit, at rest, all of that is fully managed by ElastiCache, and as a user, you don't have to really worry about automated certificate issuance, renewal, etc. And finally, of course, as all other services within AWS, you get the IAM integration for management APIs. Recently, ElastiCache for Redis has also undergone compliance certification, so the service is fully compliant, whether it's HIPAA compliance, PCI, or FedRAMP. And lastly, really quickly touching upon high availability and reliability before we get into the scalability aspects. So with ElastiCache, you essentially have the ability to use read replicas for read availability as well as scalability. The multi-AZ autofailover feature essentially lets you automatically set up your cluster for scenarios where the service can detect any failures and promote replicas and repair failed nodes in the process as well. Now, we will be talking about Redis cluster configuration extensively in the next several minutes, but the key thing also from an availability standpoint is to think about the faster failovers and the availability improvements that the Redis cluster offers. Now, finally, in terms of scalability itself, with Redis cluster configuration, you can scale your memory as well as throughput for your application's needs. The cluster configuration within ElastiCache allows you to support up to 6.1 terabytes of in-memory data. And this is done by essentially using multiple shards. ElastiCache supports up to 15 shards today, and each shard has a primary node and up to 5 replica nodes across AZs for read scalability. So I briefly mentioned the Redis cluster mode a couple of times, but just to level set as we go deeper, with Redis, there are two topologies that are available. Both are compatible with open source Redis, and ElastiCache offers the cluster mode disabled topology and cluster mode enabled. Now with the cluster mode disabled or the classic Redis API support, you essentially get one primary endpoint with up to 5 replicas that can be added with that primary. And so the entire key space within Redis is contained in that one primary endpoint. Whereas if you look at the non-cluster, if you look at the cluster configuration, your data is being partitioned across up to 1 to 15 primaries, or shards as we call it, and the key space then gets divided across these primaries. Each primary can continue to support up to 5 replicas, which is very similar to the classic configuration or the cluster mode disabled configuration. But the main thing you'll notice is the difference in just memory scalability itself. Okay, so real quick, the two modes that we just talked about, the Redis cluster mode enabled, which is more scalable and highly available configuration, and the Redis cluster mode disabled, right? So with the Redis cluster mode enabled, your data is partitioned across multiple shards up to 15, and each shard essentially can have up to 5 replicas. The Redis cluster mode is also fully compliant with open source Redis, as is the Redis cluster mode disabled. You just want to make sure that whichever mode you choose, you are using the client ecosystem that's already available and supports the relevant configuration. With cluster mode, as we talked about, you can scale your configuration up to 90 nodes, and this comes from the 15 shards or 15 partitions on primaries that we talked about, and up to 5 replicas for each primary. So that sort of allows you to scale your cluster to up to 90 nodes. This essentially offers you higher in-memory capacity. It provides you better throughput in terms of just scaling both your reads and writes, and it also supports a higher number of connections across the primary as well as replicas. Now, something to keep in mind is that each application server will likely have to connect to each shard, so that does increase the number of connections, but overall you get better throughput in terms of both reads and writes. You get to scale to a higher in-memory capacity and increase number of connections. So that's just from a scalability aspect. To look at the high availability aspect as well, with the Redis cluster mode enabled, since you are able to actually scale out your partitions or your data, if and when a failover happens, let's say because of an underlying hardware issue, the failover only impacts a small partition of your data, versus with the disabled mode where all your data is in one primary and hence your entire data set is impacted. The Redis cluster configuration also offers faster failovers, where we see failover happening within 15 to 30 seconds. Whereas in case of the disabled mode, the failovers take relatively longer because there is an additional DNS propagation delay that's encountered in the disabled mode. And finally, I think in terms of just bringing scalability and availability together, one of the biggest benefits of Redis cluster mode enabled would be just the scaling operation itself, where you can resize your cluster in an online fashion, and you can add shards or add primaries and remove those to scale out and scale in and meet your business needs, and do it in a fully online fashion. You could also add your read replicas, add or remove read replicas in a similar online fashion, thereby having higher availability overall. Now, one common thing that does come up as customers think about Redis cluster mode enabled versus disabled is, how do the cost for the two compare? With ElastiCache pricing being node-based pricing, here's a quick example, but essentially the costs are identical in both the configurations. It's just that depending on your workloads requirements, you may choose to have a large number of smaller nodes with the Redis cluster mode enabled versus having few number of larger nodes with the Redis cluster mode disabled. And in the end, the price, based on the pricing of the node, the total cost is pretty much identical. Okay, so going a little bit deeper into the Redis cluster mode, which is really what we were talking about, the highly scalable, highly available configuration from ElastiCache. Now, what happens in a Redis cluster enabled mode? So, as you might be aware, with Redis, you essentially get 16 384 hash slots, and these are available per cluster. Now, the slots are distributed across shards. So when you're using a cluster mode enabled, your slot space is essentially partitioned across shards. So the only thing from an application standpoint that you need to do to use Redis cluster mode enabled is to make sure that you're using a Redis cluster aware client. Now these clients are fully open source compatible. The ElastiCache Redis cluster configuration is fully compatible with the Redis cluster APIs available in open source. And what these clients can then do is they can discover the configuration on the server side. And clients, depending on which client it is, each client sort of has its mechanism to maintain or store sort of a map of the slot space. And this allows the clients to redirect to the correct shard based on the slot that it's trying to access. So here's a quick example where it shows data is being partitioned into 5 shards. And you see the slot space divided uniformly across the 5 shards. And that's happening through the Redis client ecosystem itself, where it's able to discover and direct requests to the correct shard. So here's a quick look at how the Redis cluster architecture itself looks. What I'm showing here is essentially a 3-shard cluster. As you can see, the 3 shards which are color-coded, each shard having a specific slot space that it addresses or contains. In this example, I've shown 2 read replicas per primary or per shard. So very quickly sort of showing, calling out these shards, you can see the first shard, which is highlighting the slot space, the first shard with the primary and 2 replicas, and it's distributed across 3 availability zones, A, B, and C. You could set up your cluster by manually selecting these AZs as you create your cluster, or you could let ElastiCache auto-select the availability zones for you as you create your cluster. So that's your first shard. You can see I'm just highlighting the second shard as well, where the slot space is distributed. You have the primary, in this case in availability zone B, and 2 replicas for that shard in the alternate AZs. And finally, this is your third shard, which is again distributed across the 3 AZs. So let's talk a little bit about what happens in case of failure. So in this scenario, you have a 3-shard cluster. Each shard has 1 primary and 2 replicas, which are right now distributed across availability zones. Now, let's say a single primary fails due to underlying hardware issue or needs to be replaced. So in this case, the replica gets promoted, automatically gets promoted to become the new primary for that shard. And this promotion happens fairly quickly. You should see this happen within 15 to 30 seconds. And then the node that was failed is automatically repaired. Now here's another case where majority of your primaries are failing, and we'll see how the scenario is handled seamlessly again from the cluster itself. So in this case, both your primaries or 2 primaries have gone down, and again automatic failure detection happens, and the new replicas across different AZs are promoted to become the new masters. So with the high availability, let's talk about how you would now scale your Redis cluster itself. So let's say you have a cluster with 3 shards, and for simplicity I'm only showing the masters here, or the primaries here. So let's say you have 3 shards and your data is partitioned uniformly across these 3 shards. And based on your business needs, you realize that you're expecting a big surge in your throughput or memory requirements, and you need to scale out. So we have a very simple API from ElastiCache, which does provide you one-click option to sort of reshard the cluster and add new shards without any downtime. So when you add 2 more shards, essentially what ElastiCache does, it seamlessly manages and distributes your slot space across the total new shards that are available now, which is 5 shards in this case. And all of that happens behind the scenes without any intervention from the user. It's the one-click operation where the cluster continues to stay online. So there is no interruption for your application, and your application continues to work seamlessly. The cluster supports both reads and writes as all of this is happening behind the scenes. And in the end, you get a uniform slot distribution across the new number of shards that you now have in the cluster. So in the end, as you got a scaled out cluster, we can essentially do the same thing to scale in the cluster. So let's say now this is your new configuration with 5 shards, and you pass the peak surge in your business application, and you need to scale in again. Just the same way as you scaled out, you can basically scale back in and specify that you want to remove 2 shards. And so you're back to 3 shards, and the slot space is now uniformly distributed across the 3 shards that remain in the cluster. Again, all of this happens with one click, no application interruption, and no client-side changes needed from your end. So one of the things that we do see our customers do today is using the power of integration with Amazon ElastiCache and setting the right triggers to do what I just showed you automatically, right? So let's say you're monitoring your CPU metrics or memory metrics with CloudWatch, and you detect the need to scale. And what you could do is you could set up a Lambda function to then trigger a scale out operation within ElastiCache. So you could go from 3 shards, resize your cluster to have 5 shards, and then as your memory requirements go down again, you could do the same thing to scale back in. One more cool thing which I didn't talk about here in the operation is not only can you add shards or remove shards, but you can also just rebalance your slot space across existing shards. So let's say you have 5 shards and you want to stick with those 5 shards. You could also call a rebalance operation to make sure you get a uniformly distributed slot space across those shards. Now, quickly want to talk about a little bit sort of what's under the hood. This online cluster resizing that we just talked about to add or remove shards. How is that actually happening, and how is it different from open source Redis? So one of the main things based on which this whole online cluster resizing works is ElastiCache is using atomic slot migration under the hood. And what this means is, instead of doing atomic key migration, which open source Redis comes with, ElastiCache uses the slot as an atomic unit to do the whole migration. What this does is it also ensures that the source shard, like when you're distributing your key space, it makes sure that the source shard is actually retaining the ownership of the key during the entire slot migration as you scale out. Right, so as we saw earlier, when you're adding shards, you're essentially redistributing the key space across the total number of shards that you now have available, and retaining the ownership with the source shard until all the keys are actually migrated gives you several benefits. Specifically, it makes it easier to support operations such as multi-key commands, transactions, and Lua scripts, thereby giving you full API coverage while the cluster resharding is in progress. It also allows the source shard to essentially continue to support requests related to the keys that have already been migrated to a new shard. And what this does is it essentially minimizes the time window that requires redirection from the client, thereby giving you better latency during the process itself. Now, the other benefits from sort of doing this atomic slot migration come from improved robustness in the system. So let's say if there is a failover during this whole migration process, what happens is, as the key ownership stays with the source shard, the replicas in the source shard have an up-to-date information on the keys. Right? And so if there is a failover, the replicas can simply continue serving the commands with the latest key status. Any other errors, such as if, let's say, the target shard goes out of memory, or other errors which may halt migration, they're much easier to recover from and are being handled seamlessly within this whole online cluster resizing process itself. Some of the other changes that we've sort of made along the way is also making sure that the whole migration process to sort of resize your cluster is actually being handled as a parallel or a separate thread from the main IO thread. So what this does is this essentially makes sure that the key migration is no longer blocking the IO on the cluster. And so there is no availability impact. All the data mutations also that happen during the migration operation are asynchronously replicated to the target shard to maintain consistency. So all in all, with the changes that we made under the hood, give you that fully online experience, continuous support for all the command set, and making sure that you can resize your cluster seamlessly without any interruptions. Now, the next thing quickly want to talk about is just the way we are adding or removing shards to get higher throughput or increased memory. You can also add or remove replicas to get better read scalability, flexibility. So say, for example, you have a 3-shard cluster, which is again in this case set up in multi-AZ fashion. And for each shard, you have 1 replica. And you realize you need to scale your read, so you need to add more read replicas. You can do this with one-click API today, where you can essentially specify you want to add 1 more replica across all the shards, and you can move to replica configuration seamlessly without any downtime. You can do the same thing to remove replicas as well, going from 2 replicas, in this case, down to 1. Right, so all of this again is handled seamlessly. All you need to do is specify the number of replicas that you want to have for each shard in terms of meeting your read scalability requirements. So in summary, just with the benefits of having a fully online cluster resizing ability, you can essentially right-size your clusters, improving efficiency and reducing cost. You get fully online experience, which ensures availability, performance, durability, and data consistency throughout the slot migration process. Your cluster continues to serve incoming I/O requests while the operation is in progress, and you get full Redis API coverage, including operations such as multi-key commands, transactions, and Lua scripts. Finally, as I talked earlier, the whole operation is fully compliant with Redis cluster client behavior, and so no application changes are needed from your end. So with the Redis cluster mode, you essentially get to scale up to 6.1 terabytes of in-memory capacity, up to 20 million reads per second and 4.5 million writes per second, increase number of maximum connections. You can resize your cluster, whether it's adding or removing shards or adding or removing read replicas, all of that in an online fashion. And you get extremely fast failovers with 15 to 30 second with limited shard impact, which is really just the shard that is undergoing failover. The entire Redis cluster configuration that's supported within ElastiCache is fully compatible with open source Redis, and it's current with Redis 4.0 support. You get the Redis cluster client ecosystem that you're used to today. And it is enterprise ready from Amazon with capabilities such as security, encryption in transit, encryption at rest, and compliance as well. To sum it up, I'm quickly going to cover some best practices for the Redis cluster configuration, making sure that you're right sizing and keeping the memory, specific amount of memory, 25% memory reserved with some room to grow as well. Reviewing your eviction policies, making sure when you're scaling up or scaling out, you do that well in advance, and also using optimized nodes for cost effectiveness. In terms of performance overall, it's always advised to benchmark using the Redis benchmark tool so that you know whether you're looking for more read IOPS, write IOPS, or network in general. The operation we talked about to sort of resize your cluster, the online cluster resizing itself to either remove shards can be CPU intensive. And so before you sort of reshard your cluster, make sure you've tested the cluster in the operation in a staging environment, and you're doing it well in advance, and ensuring that there's actually sufficient memory available if you are scaling in. I think these are certain common practices to make sure you are set before you actually initiate your resharding operation. And finally, during resharding, since it's a CPU-intensive operation, avoid using expensive commands and follow other best practices such as avoiding long-running Lua scripts, declaring the keys used in Lua scripts upfront, etc. Now, we do see in terms of just the Redis cluster configuration with the scale and performance that it delivers, we see it being used across a wide variety of use cases really, specifically with very demanding applications such as leaderboards, streaming data analytics, social media, sentiment analysis, etc. So anywhere where you need extreme scale and throughput, you need the speed and high availability, and you need the flexibility to respond to variability in workloads. Redis cluster configuration is a great fit, which allows you to sort of manage your surges and declines with online cluster resizing. To wrap it up, I'll leave you with these customer use cases and testimonials, where two of our very well-known customer names, Duolingo and Dream11, talk about how they have been actually using the Redis cluster configuration to get the extreme scale, extreme performance, and the flexibility to sort of right size in an online fashion with the ElastiCache for Redis cluster configuration. If you're curious to learn more, feel free to access one of these links and learn more about Redis cluster configuration, resizing, and getting all the benefits that we just talked about. Thanks again for joining us. Time for any questions as needed.